All right, working related rate problems. We have the radius r of a sphere is increasing at a rate of 1 meter per second. What is the rate of change of the volume when r is equal to 2 meters? So that's going to be the first question we need to deal with. And then the second question here is we got to find the rate of change of the radius when the rate of change of the volume, dv over dt, is equal to 20 cubic meters per second. And looks like the volume is equal to pi. Okay, so let's go back up here, and I want to say something here that I don't have yet in any of these problems. Sometimes they get tricky in their wording, and it kind of tricks some people up, but it'll say, for example, the radius r of a sphere is decreasing at a rate of 1 meter per second. Well, if it says decreasing, then that means in the problem we don't put 1 into the problem for dr over dt, but we put -1 in. So be careful, you put negative in if it says decreasing. That's something I failed to mention in some of the earlier problems. So if that says decreasing and that's a positive there, you need to make sure that in the problem you put in a negative. For example, this would be -1. But this says increasing. Okay, so is increasing, so that'd be dr over dt is equal to 1. And it says what's the change of the volume, so that'd be dv over dt is what we're looking for when r is equal to 2 meters. So let's get busy. So we're going to need to know the relationship between the volume and the radius, and that's something I think you should probably have had memorized or should memorize or something like that. But it's a 4/3 pi r cubed, right? That's going to be the volume. And so we're going to take the derivative of this. So the derivative of v is going to be, remember, with respect to t here, because these are related rate problems. And so we have dv over dt is equal to, we take the 3, bring it out front, and of course 3 times 4/3 is just 4, right? And then pi r squared, subtracting 1 from the exponent, and remember we tack on a dr over dt outside. So there it is, and now what we need to do is pretty much plug everything that they give us into that. And so we said that the radius was 2 and dr over dt is 1. Remember, that was 1 meter per second. And so we simplify all that stuff down and we end up getting 16 pi cubic meters per second. Okay, let's look at the second part to this problem. We got to find the rate of change of the radius. So we're looking for dr over dt when the rate of change of the volume is dv over dt is 20, and they're giving us that the volume is equal to pi cubic meters. So I think we're probably going to need to know this one this time. We're going to be using it. So dr over dt is what we need to find. So once again, we write out the equation to the volume of a sphere, and then we take the derivative, and this time we're looking for dr over dt. Now they gave us dv over dt, and they gave us the volume. So, but what they didn't give us is what is r, right? They didn't give us that. So when the volume was pi, which I've got written right here, we need to just go ahead, we set v equal to pi, and then pi is equal to, right, all this other stuff, whether it's pi r cubed, and then we're going to solve for r here. So we end up getting r is equal to 3/4 raised to the 1/3 power. Right, your pi's cancel out, take the 3 up here, the 4 down there, and raise both sides to the 1/3 power. Okay, so there's our r. So now we can go ahead and plug our r in, right, and dv over dt, we know what that is. Right, so we plugged our dv over dt in, which was 20 cubic meters per second. And so now we got this equation here, and we need to solve for dr over dt. Okay, don't worry about this down here. This is the next problem. But we end up solving for dr over dt here, doing a little algebra, and we end up with dr over dt is equal to, now, you know, you need to try to, this is nothing but just some little bit of algebra here in order to get to this point right here. And of course I don't do any approximating, I just leave it in the exact value. And remember, don't forget your units. This is meters per second. And of course, if you want to get a grip on what this is, you plug it in